Hello everyone, this is Dr. E, and for today we're going to be working on the ASA and AAS triangle congruence. In geometry, we have numerous ways on how we can prove that two triangles are congruent, and for today, we're going to use the ASA and AAS postulates to prove that the pair of triangles that we are seeing are indeed congruent. So let's start with the angle side angle postulate, or ASA postulate, wherein if two angles and the included side of one triangle are congruent to the two angles and the included side of another triangle, then the two triangles are congruent. Take a look at the diagram that we are seeing right now. This is basically the conditional statement for the ASA postulate, wherein we are seeing that angle A is congruent to angle D, and side AC is congruent to DF, and angle C is congruent to F, and we notice that they are also corresponding. Therefore, triangle ABC is considered to be congruent to triangle DEF using the angle side angle postulate. So let's see if we can use the ASA postulate and choose the congruent triangles based on the four triangles that we are seeing on the screen. So for the first triangle, we can see that this fall under the form angle, angle, and side from the diagram that we are seeing. And for problem or for triangle letter B, we are seeing another pattern wherein we have an angle, side, angle with the common markings that we are seeing for congruency. So let's label it down as angle, side, angle. So we are seeing a pattern that we know is an ASA postulate possible pairing for another triangle. So let's just keep on looking for that triangle. So for triangle letter C, we are seeing another type of markings, but this time we have angle, angle, and side form in our triangle, so we will name it as AAS. And for the last triangle, we are seeing the angle, side, angle to be congruent. So in this case, by marking the correct position of our triangles, we know that triangle B and triangle D are congruent using the ASA postulate because of the corresponding parts that falls under that form. And we are seeing the other two triangles A and C to have the AAS form, and your guess is as good as mine. Yes, we also have another postulate for triangle congruence called the AAS postulate. And from here, we are seeing that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are considered to be congruent. So take a look at the diagram that shows the AAS postulate, and we are seeing that angle A is congruent to angle D, and we are seeing that angle B is congruent to angle E, and the non-included side, and the reason why it's not non-included is because it doesn't connect with the two angles that are also congruent to each other. That's why it's called non-included. So we have line segment AC that is congruent to DF, and it's non-included because you are seeing that B and E, or angle B is detached to AC, and line segment DF is detached to angle E. So in this case, the AAS postulate holds, therefore ABC is congruent to DEF. So let's use these postulates to prove that two triangles are congruent, and we are seeing a kite-like figure and a bisector. And we know it's a bisector because it's given in the problem. DB bisects angle ABC, and angle 1 and angle 2 are congruent. And every time we work with two-column proof, it's always good to draw the figure, even if our drawing is not as pretty as the original drawing, but by doing so, we'll be able to identify the postulates and theorem we will use to prove that this triangle is congruent to this triangle. We will name this point as A, B, and C, and this point right here is point D. And we know that 3 and 4 is also in the marking, and we also know that 1 and 2 are considered to be congruent because it is given. So now that we have our diagram, let's start with the first line, and we know that the first line is always the given information. So this will be our two-column proof. This will be our statement. And this will be our reason. And this is called the two-column proof. So the first line of our proof is that we know that dB, ray dB, bisects angle ABC. And we know that because it is given. So now that we have the first line, from here, we know that if this is a bisector, we know that 3 and 4 will also be congruent because that's what the angle bisector do. So for our second line, we can say that angle 3 is congruent to angle 4 because of the definition of an angle bisector. Forgive my handwriting, but we know that from here, we are seeing that that is the angle bisector, and it bisects ABC. And we now have angles that are congruent, which is angle 3 and 4. And we know that because that is the basic nature of a bisector. It cuts the angle into two congruent parts. And from here, what we can work with is how we're going to connect angle 1 and angle 2 because this is given. So let's write it down. So 3, angle 1 is congruent to angle 2. And we know that because it's also given. And from here, we can see that this angle and this angle is forming a pattern. And all we need to do is to use the relationship between this line segment to use the postulate that we've just had today, and we'll just say that dB is equal or congruent, not equal, to line segment dB because of the reflexive property of congruent. And we need to establish that because we're going to show that these two triangles can be separated, and when they are separated, we are forming a congruent side. So now we have the ASA postulate to use so that we can say that triangle DAB is congruent to triangle DCB using the A angle, side, angle postulate. And this is how we use or write a two-column proof by using our pattern, of course, understanding the postulates, theorems that we can use to articulate our reasoning. So we know that angle 1 and 2 are congruent because it is given. And we also know that dB is congruent to dB, and we need to establish that so that if we are going to separate the two triangles, we know that they are congruent. And by doing so, we are able to establish that triangle DAB is congruent to triangle DCB using this postulate. So now we know that they are congruent. So we have this ASA triangle postulate that we can use to prove that the triangles are congruent. So this is how we use our postulates in proving this figure or triangles that we are seeing to be congruent using the ASA postulate. Now let's have another pair of triangles and let's prove that they are indeed congruent. So we are seeing our given, and we are seeing what we need to prove, which is triangle ABC is congruent to DEC. And the first line is already done for you. So just like what I have mentioned about two-way proof or two-column proof, it's always good to start with your own drawing or sketch so that you can be more familiar with what you're going to do to prove that the two triangles are congruent. So even if your drawing is ugly like mine, hopefully I'm doing it right. We know that this is a right triangle, even though it doesn't look like it, but we know that this is right because it's given. And 1 and 2 are angles that we know are vertical by just looking at it. And we also know that we have a midpoint right here. We call it midpoint C, and we just did not write this down because it's also given. We know that this is point A and point B, and this is point E and point D. And now that we have our diagram and we have our first line, which is angle B is congruent, angle B and angle E are both right angles. And we know that because it is given. And since we already have that established, let's use B and E because now we know that since they're both right angles, because it's given, we can also say that angle B is congruent to angle E because they are right angles, and that is the definition of a right angle. So angle B and angle E, we can say that they are congruent, and we can write the reason for that is that it's the definition of the right angles. And now that we have established our second line, let's take a look at this line right here. And this line right here, line segment AD, has a midpoint. And that midpoint is midpoint C. So we can include that in our statement that C is the midpoint of line segment AD. And we know that because it's given. And why do we need to establish that? Because I want to show that line segment A is congruent to line segment D because this is the midpoint, and we know that the definition of the midpoint, it cuts the line segment into two congruent parts. So this line segment is equidistant to CD. So we can say now for our line 4 that AC is congruent to line segment CD. And we're able to show that because of the definition of a midpoint. And now we are seeing that all we need to do is to show that angle 1 and angle 2 are congruent, and that is easy because we know that this is a vertical angle. So by doing so, we know that line 5 is that angle 1 is congruent to angle 2 because of the definition of the vertical angles. And by doing so, we're now able to establish angle, angle, and the non-included side to be the postulate that we can use to prove that triangle ABC is congruent to triangle DEC because of the AAS postulate. And we can also use another reason why they are congruent. And if you can remember the third angle theorem or third angles theorem, this and this can also be congruent because of that particular theorem. But since we are now able to prove that they are congruent after line 6, we will stop here, and we know that we're able to prove that those two triangles are indeed congruent. So going back, we know that line segment AD is what we used to establish that C is our midpoint for line segment AD. And by doing so, AC, or line segment AC, excuse me, is congruent to line segment CD. And this is important because now we're able to establish the postulates that we have just covered a little while ago. And we can say that angle 1 and 2 are also congruent because of the vertical angles theorem. And by having those items in our pattern, we can say that triangle ABC is congruent to DEC because this angle, and this side are congruent to the corresponding angle, side of triangle CED. So we're able to prove using the AAS theorem that we have two congruent triangles. And for your number bender challenge for the day, of course, you have two triangles that you need to prove that are congruent. And to be able to do that, comment it down below, write down your reasons, and how you're able to prove that triangle ADB is congruent to triangle CDB. And that is our lesson for our geometry video for today, and understanding your postulates, your theorems, and recognizing those postulates that can be applied to your diagram will be your first step in understanding how to write a two-column proof, because a two-column proof, or the skill that you will acquire in understanding how to write a two-column proof, will greatly help you practice how to think critically and analytically. This is Dr. E, and see you again next time. Bye!